Aim: to demonstrate the reflection and transmission of waves at the boundary of two media. Materials required: steel hook on the stand, a movable ring on the horizontal rod, long heavy spring, fine thread, slinky. Procedure: reflection of the pulse at the fixed end. Take the slinky and tie one end to the steel hook. Hold the other end of the slinky by the hand. Stretch the slinky. Give a pulse to the free end of the slinky. Observe the reflection of the pulse at the fixed end. Observation: the pulse reflected with inversion at the fixed end will have the same speed as incident pulse. Reflection of the pulse at the free end. Tie the fine thread to the movable ring. Tie the fine thread to the slinky. Hold the free end of the slinky. Give a pulse to the slinky and make sure that the pulse is parallel to the horizontal rod. Observe the reflection of the pulse at the boundary of thread and slinky. Observation: the pulse reflects without inversion, maintaining the same speed. Pulse travels from rarer medium to denser media. Join a helical long spring of high mass to the slinky. Attach heavier spring to steel hook. Hold the free end of the slinky. Stretch heavier spring and slinky. Give a pulse to the free end of the slinky. Observe what happens to the pulse at the boundary of the two media. Observation: after the incident pulse reaches the boundary of the heavier spring and slinky, two pulses are observed. The transmitted pulse passes through the heavier spring and the reflected pulse reflects the slinky. Transmitted pulse: this pulse travels at a low speed through the heavier spring and the amplitude of the transmitted pulse will be lower than that of the incident pulse. Reflected pulse: this pulse reflects at the boundary and passes through the slinky. The speed of the reflected pulse matches that of the incident pulse. The amplitude will be lower than that of the incident pulse and the reflected pulse will be inverted. Pulse travels from denser media to rarer media. Tie the slinky to the steel hook. Join heavier spring of higher mass to the slinky. Hold the free end of the heavier spring. Stretch the heavier spring and slinky. Give a pulse from the heavier spring to the slinky. Observe what happens to the pulse. Observation: transmitted pulse. It travels through the slinky with a higher speed and higher amplitude than the incident pulse. Reflected pulse. This pulse travels through the heavier spring at the same speed as the incident pulse. The amplitude of the reflected pulse is lower than that of the incident pulse. Conclusion: the speed of the pulse in rarer media is greater than in denser media. The speed of the pulse depends on the density of the medium through which it travels. When a pulse reaches the fixed end of a medium, it gets reflected with inversion. When a pulse reaches the free end of a medium, it gets reflected without inversion. When a pulse travels from a rarer medium to a denser medium, some part of the pulse gets reflected with inversion.